Hi, everyone. In this video, I want to discuss vectors. Specifically, I'm going to discuss two-dimensional vectors. And I'm going to do so from the perspective of a computer programmer, or basically a game programmer, or a graphics programmer. I'm not going to get too heavily into the math that's involved in the algebra, but I will leave some links below in case you want to research that topic a bit more, because it's very helpful to understand this math. But right now, I want you to understand the basics. Before I get into the vectors, I just want to make sure you understand what the differences between a vector and a point, and also what is this here. This is a graph, and I'm going to show you the Cartesian coordinate system, basically. And this center point here is 0, 0. Normally, when we were dealing with computers, the 0, 0 point on your screen would normally be up here, or it would be down here in the bottom left corner. But it's not like that in the Cartesian coordinate system that you're going to see in your geometry books. In the Cartesian coordinate system, you have a y-axis here, and the y-axis increases as you go up, positive, and it's negative as you go down. And the x-axis is over here, is going to increase positive as you go to the right, and then it's going to be negative as you go to the left. Well, on a computer screen, as most of you already probably know, 0, 0 is up here, and y increases when you go down. And x increases, of course, when you go to the right. So the x-axis is the same, although we always stay in this quadrant over here. We never go into negative screen space. But everything that I'm going to explain here still applies. So a point, if we're going to discuss a point is just a point in space. It doesn't have any dimensions to it. So if I wanted to create a point is usually represented as an x and a y location, right? Okay. So if I wanted to draw a point at 3x, I would move across to 3, and then I want to draw it at, let's say, 4y. So I would move up to 4y. This point is at 3x and 4y. And again, it's just a point. It doesn't have any dimension to it. It's just a point in space. Now, a vector, on the other hand, has two components. One of them is the magnitude or length of the vector, and the other one is the direction. So if I draw a vector on here, okay, let me draw it up in this direction here. So this vector, this would be the length of the vector, and its direction here is roughly, let's say, 45 degrees. Okay. Now, degrees are measured beginning at the x-axis, and it goes around to 90, 180, 270, and 360. And this is roughly, so this vector here is 45 degrees at a magnitude. Now, the magnitude of that vector, again, is the same thing as the length. This is called the tail, and this is called the head, okay, or the terminal point. So the distance from the tail to the head is the magnitude. Now, we could represent a vector in different coordinate systems. And one of them would be, for example, in polar coordinates. Polar coordinates has the angle, okay? So that would be the angle around this axis or around the origin. I really need to get a drawing tablet. So that would be represented by the angle, comma, and then the magnitude, okay? So all it needs is those two values to reconstruct this vector. Now here, we're not working in polar coordinates, we're working in Cartesian coordinates. And the Cartesian coordinates will be an x and a y component, just like we had for our point. Well, this vector, it looks to be 1, 2, 3, 4, 5. So it's 5x, okay? And then we're looking at 1, 2, 3, 4, 5, 6y. So those are the two vector components here, 5x and 6. Okay. Now, I want you to know that, again, vectors are always assumed to be drawn from a 0, 0 origin point. But that doesn't mean they need to be in this location to be the same. I could go over here, okay, and start here. Now our vector goes 5 along the x-axis. So I could go 1, 2, 3, 4, 5, okay? And then I could go up 6. 1, 2, 3, 4, 5, 6, right here, okay? So I could connect those. And this vector here is identical to this vector. It's got the same run along the x-axis and the same distance along the y-axis. All right. Now, you may be saying, well, how do we know the magnitude? Well, if you remember from high school algebra, the Pythagorean theorem, if we look here, what we have, if you look at this, is basically this would be the opposite side, okay? And this would be an adjacent side, okay? So that's the adjacent side, the opposite side, and then this would be the hypotenuse, okay? This here is a 90-degree angle. So if we wanted to know the magnitude of it, we would use Pythagorean theorem, which basically is x squared plus y squared, and then you would take the square root of that. Okay. So this formula here, if I took 5 times 5 plus 6 times 6, and then took the square root of that result, that would give me the magnitude. Again, a vector is two things. It's a magnitude and it's a direction. All right. So what could vectors be used for? Well, vectors could be used for a lot of things in computer graphics. For one, you might want to keep track. Let's say you had a car, okay, and the car was traveling on the screen and it's moving, and you're going to want to know, well, what direction is it moving, and how fast? What is its velocity that it's moving? So you could represent that as a vector. Another thing you could do is represent gravity. Of course, gravity is always moving straight down, and then gravity would be applying a downward force on this. So whenever you're doing physics stuff, you would use a vector for that. And there's many, many other things that you could use vectors for. They're very powerful. But before we do any of that, I want to explain some of the math behind vectors, and I'm going to do that in the next few videos. Hope you have a great day. And if you like this video, please click like below, and please share this video and subscribe for my future videos. I'm going to be putting out a lot of stuff related to game programming. And I'm going to try to take topics that might seem difficult to a lot of people and simplify it. So I hope you have a great day. Thank you. Peace.